For topic 6, we're going to look at multiplying polynomials with multiple variables, okay? The good news is it's exactly like multiplying polynomials in single variables. You're just dealing with two variables instead of one, so it's like an extra layer that you have to worry about, but you don't do it tons and tons and tons, but it's a good skill to know, okay? So when we're multiplying polynomials in multiple variables, we're going to follow the same steps that we did in a previous section where we just had single variables, okay? So what we're going to do is make sure each term in the first polynomial is multiplied by each term in the second polynomial and then simplify as needed. Okay. So for example 6, it just says find each product. So for part A, this is setting us up very nicely to basically do the FOIL method. Okay. So remember, for the FOIL method, make sure I've got, there we go. For the FOIL method, we're looking at multiplying the first terms, then multiplying the outer terms, then multiplying the inner terms, then multiplying the last terms. That's what FOIL stands for. But for me, what I'm going to do is I'm going to start with this x. I'm going to distribute it through the second polynomial. Then I'm going to take the 9y and distribute it through the second polynomial. And that just kind of naturally does the FOIL method. Okay, so let's go ahead and start. So for part A, well, example 6 says find each product. But for part A, we have x plus 9y times 6x plus 7y. So I'm going to start with this x right here, and I'm going to distribute it. So I take 6x right here times the x in the first polynomial. So x times 6x is 6x squared. And then I'm going to take that same x and multiply it by 7y. So that would give me plus 7xy. I'm done with the x. I don't need to do anything else with it. It's been distributed. I now need to pick up the 9y. So 9y times 6x, we take 9 times 6, which is 54. And then y times x is the same as x times y, so I get 54xy. And then I'm going to take that 9y and multiply it by 7y. So 9 times 7 is 63. And then y times y is y squared. At this point, you always want to look to see if you have like terms, and we do. These middle terms both have xy as the variable, okay? So I'm going to bring down my 6x squared. And then 7xy plus 54xy would be 61xy plus 63y squared. And that would be our final answer. Okay, so just make sure you multiply each term in the first polynomial by each term in the second polynomial, combine like terms as needed. Okay, now part B is a tricky one. This is something that students get wrong all the time. Okay, so if I were to have something like a plus b quantity squared, this is not the first term squared plus the second term squared. You've got to erase that from your head. That's not what's happening here. What's really happening is if we have a plus b quantity squared, the base is the a plus b, and we're multiplying a plus b times itself twice. So this would equal a plus b times a plus b. So we would want to do the FOIL method. So let's just first rewrite this polynomial as the product of two binomials, okay? And then we can do the FOIL method and then simplify. So instead of leaving this as 2x plus 5y quantity squared, I'm going to write this as 2x plus 5y times itself twice. So times 2x plus 5y. And then I'm going to do exactly what I did in part A, okay? So I'm going to start with 2x. I'm going to take the 2x and distribute it through the second polynomial. So 2x times 2x, well, 2 times 2 is 4. X times x is x squared. And then 2x times 5y, well, 2 times 5 is 10, and then x times y is just xy. We just write them side by side. Okay, I'm done with the 2x. I don't need it anymore. It's been distributed. So now what I'm going to do is I'm going to pick up the 5y and distribute that through the second polynomial. So 5y times 2x, well, 5 times 2 is 10, and then y times x is the same thing as x times y, so 10xy. And then finally, I get 5y times itself, 5y. So 5 times 5 is 25. Y times y is y squared. And we want to now look to see if we could simplify. Is there anywhere that we could combine like terms? And the answer to that would be, well, yes. We've got this situation in the middle where we have two terms that have an xy for the variable. So when we clean this up, our 4x squared just stays 4x squared. There's nothing to combine it with. And then 10xy plus 10xy, those are like terms. So 10 plus 10 is 20. So I get 20xy. And then there's nothing to combine with 25y squared, so I just bring it down. So as you can see, it's the same process as before where we just had a single variable. We're just kind of adding that layer of this second variable, but it's nothing really new. It's still just the product rule and then the FOIL method, okay? Now, next up, we have part C, where we have 6x plus 7y times 6x minus 7y. And this is a situation where we're dealing with something called conjugate pairs. So conjugate pairs are really cool. They simplify very nicely, and you will see them a few times in this course, okay? So when you have conjugate pairs, you have a binomial, so any old binomial. So let's say we have a plus b. Then its conjugate pair is going to be the same terms, but a different sign in the middle. So the first term is going to be exactly the same, and then for the second term, we're just going to have the opposite of it. And what's really nice about these is when you multiply, things kind of collapse out in the middle. So if I were to do just the FOIL method here, I'm going to do it really quick down at the bottom. I would get a squared minus ab plus ab minus b squared, and you're going to end up with a plus and a minus of the middle terms, and they'll always kind of collapse out. They just become zero, and you're left with the first term squared minus the second term squared, okay? This is not like anything, like it's not some weird trick. It's just a shortcut to the FOIL method, okay? Now, if you're more comfortable doing the full FOIL method, that's great. Or you can just take the first term and square it, and then take the second term and square it and subtract, okay? I'm going to do the full FOIL method just to prove to you it's all good, and then we can do the shortcut to like really show that this works. So if we do the FOIL method first, we're going to start with this 6x in the first polynomial and distribute it through the second polynomial. So we would get 6x times 6x, which is 36x squared. I could then take 6x times negative 7y, which is negative 42xy. I'm done with the 6x. I don't need to do anything else with that. I need to pick up the 7y and distribute it through the second polynomial. So 7y times 6x, well, 7 times 6 is 42. Y times x is the same thing as x times y, so we get 42xy. And then 7y times negative 7y, well, 7 times negative 7 is negative 49. Y times y is y squared. And we always want to look to see if we can simplify after doing the FOIL method. And if we look at these middle terms right here, sorry, I need to get a sip of water. Okay, and if we look at the middle terms, we have negative 42xy plus 42xy. Negative 42 plus 42 is just 0. So those middle terms kind of collapse out, they cancel out, and we're left with 36x squared minus 49y squared. And just to prove that this conjugate shortcut here works, where you can just square the first term, square the second term, and subtract, if I take the first terms and square them, so that first term squared is, well, 6 squared is 36, x squared is x squared. Take the second term, square it, that's really just 7 squared, which is 49. Y squared is y squared, so we get 36x squared minus 49y squared. The only reason this works is because we have this plus here and this minus here, okay? So if you're more comfortable just doing the FOIL method and letting things naturally collapse out, that's fine, okay? Last up, we have a binomial times a trinomial. It's a little more involved, but it's the same process. You're going to take each term in the binomial and distribute it term by term through the trinomial, and then simplify if you can. So let's go ahead and start. I will say these tend to be a bit longer, so just be really careful, double check your signs, okay? We're going to start with the x, and I'm going to distribute that x through the polynomial or the trinomial. So x times x squared, well, that's x to the third. And then I get x times 5xy. Well, 1 times 5 is 5. X times x is x squared, and then just leave the y. Okay? And then x times y squared is xy squared. Okay? So we're finished with the x. We don't need it anymore. We can move on to the y. Y times x squared is x squared y. Y times 5xy. Well, 1 times 5 is 5. There's nothing to multiply by the x, so I just bring it down. And then y times y is y squared. And then finally, we get y times y squared. Well, y times y squared ends up being y to the third. And when we get to this idea of writing things in standard form, it gets somewhat complicated when you have multiple variables. So I'm going to write this in what I consider standard form. We do need to combine like terms in a couple of places. I'm going to start with the variable that shows up first in the alphabet, which would be x. So I'm going to take x to the highest degree that x has. So that would be x to the third. Then I'm going to take x to the next highest degree, which would be anything with an x squared. So do we have stuff with x squared in it? Well, yeah, we do. We have 5x squared y, and then we have just 1x squared y. As long as the variable parts match identically, we can combine like terms. So we have x squared times y to the first. We've got 5 of them, and then we've got one of them by itself. That means we have 6x squared y. And then I want to take that variable that shows up first, which would be the x, and I want to take it all by itself. So if I just have a single x anywhere, or I don't want to say a single x, if I have x to the first power anywhere, I'm going to write those terms next, and we do. We have, let me get a different color here. We have x to the first times y squared, and then x to the first times y squared. So anything with x to the first, as long as the variable parts match identically, we can combine like terms. So I have x to the first times a y squared, and then I have an x to the first times a y squared in two different terms. I have one of them, then I have 5 of them. That makes 6 of those. So I get plus 6xy squared. And then finally, that leaves us with just one term, which would be this y to the third. So I'm going to end with that. All right. So again, don't get too bent out of shape about standard form when you have multiple variables. This is how I would write it in standard form. There may be some controversy depending on the book or the tutor that you potentially work with, but that's what I would consider standard form. At the end of the day, just get like terms combined, okay? That's what I'm most concerned with, is knowing that you can multiply and then combine like terms, okay? So that is multiplying polynomials that have multiple variables.